This episode is supported by two companies invested in advancing GPCR research, GeneTex and Eurofins DiscoverX. GeneTex is on a mission to tackle GPCR antibody reliability bottlenecks through rigorous validation and direct engagement with you, the research community. Check out their catalog and request your favorite anti-GPCR antibody sample today. Eurofins DiscoverX brings validated GPCR assay platforms built to support real drug discovery programs from discovery through regulatory review. Links to both are in the show notes. And now, let's dive into this episode.
Hello, everyone. It's Yamina from Dr. GPCR, and today I have the pleasure of talking to Dr. Antony Boucard. Hi, Antony.
Hi, Yamina.
How are you?
I'm very good, very good. Thank you for having me. It's a great platform, and I'm really honored to be invited on the platform, seeing the name of the likes of Lefkowitz and Engel. So it's a great honor to be here. Thank you.
Thank you. I'm glad we were introduced, and I'm glad we're doing this. And you know, I'm so happy. So let's dive right into it. Just before I start asking you any questions, just want to give a little bit of context. We were introduced, and to be honest, I didn't hear from you until I got that introduction email. But then when I Googled you, I was like, wait a minute, you were in Canada as well. So it's a small GPCR world, and yet there is new people to discover, and I'm glad that we're doing this finally today.
Thank you.
All right, so let's just dive into it. Who are you, and what do you do?
Yes, so I'm Antony Boucard. Well, I'm a scientist from a kind of a broad background. Started with a training in Canada, in Université de Sherbrooke. Did my bachelor degree, master degree, PhD degree there, and then I decided to move to the United States for a postdoc, where I ended up in the lab of Dr. Thomas Südhof, that a lot of people know received the Nobel Prize in 2013. So I basically moved to Dallas, and then we migrated towards California. So my background is basically a biochemist. I started as a biochemist, kind of a hardcore biochemist, and then decided to go in pharmacology, the study of receptors, and that's where I met with GPCRs. That was my first encounter with GPCRs, and then when I migrated to the United States, I focused on another aspect that was also like membrane proteins, but more like adhesion molecules, which we might talk about in a few minutes. And also at the end of my postdoc, I wanted to go back to GPCRs. So then I ended up making some sort of a fusion between those types of molecules. And yeah, so that's my background. So basically now I do a little bit of neuroscience. So I collaborate to do some behavioral neuroscience, and also some cell biology work related to the function of GPCRs. So, and still biochemistry and everything still in the pot still.
Of course, biochemistry, you can't get rid of biochemistry or chemistry at all in the field. So, but let's take a step back, and I've started asking this from everyone. Did you always know that you wanted to be a scientist?
It's kind of a very funny story, because maybe that will speak to a lot of people that are out there and that try to be don't know what to do really. And I kind of grew up in social service a lot, so being involved in a lot of kind of like organizations that help people on a community basis. So I was involved in the Army for almost 20 years. I was in the Army. I was an officer in the Army. So I was always involved in helping. So either communities that had disasters or everything, really, like every kind of like aspects of social work. And also I had decided to go work in South America to also help basically be involved in a group of women in Nicaragua that was trying to develop cooperatives, like some sort of like organizations that would people together, but it was basically only for women to be able to provide for their family. So they had like special skills. So they would like gather those skills in that organization and be able to actually generate products that they could sell. But also they would have like an ongoing type of training for people joining the organization. And also the major problem was a health problem for those women, also for their families, was that at home when they would cook, well, there was a problem with finding wood, but also there was not a very efficient way to use that wood. And when you would cook, all the smoke would basically create like a health problem for the kids. So to make that story short, I came at that moment to basically engineer some sort of like ovens, like made from everything we could find, from rocks, from excrements from horses, to sand, to make ovens that are closed and with chimneys and stuff like that. Something very simple, but that basically made the use of wood very, very efficient. So just I was coming back from this experience, and I didn't really apply for university in other than medical school. I wanted to go to medical school, and that's what I wanted. So I come back from this experience, and I was a little, I didn't really know if I really wanted to go to medical school, but I guess that was chosen for me because I was not accepted that year. So then I had this notice from the University of Sherbrooke saying that I was accepted in a program. Really, I didn't know which program it was. I know it ended with chemistry, so I thought I was going into chemistry. So I decided to go. And then when I was sitting down with all the new students, and I asked, "Oh, so this chemistry program looks very, very interesting." It's like, "Well, you're actually in biochemistry." So I think you should know that from the get-go. And then I was like, "Oh, okay, well, yeah, well, I guess I think I will like it." But my plan was always to go to medical school. So I spent 1 year in the biochemistry program. I really loved it. And I applied for medical school, and I was basically accepted a medical school, but I was already well into the second year of biochemistry, and I was already starting to be involved in labs. So from that moment, I completely fell in love. You have to imagine, like, I didn't even know what a scientist was. I had no clue what a scientist was other than the actual word. And when I could actually see hands-on what scientists were doing in the labs and the questions they were answering in the labs, I fell in love, really. And I rejected that acceptance, and I took basically a scholarship to work in a lab from a pharmaceutical agency. And then everything fell in place. I started working on proteases, and I ended up working on a GPCRs. It's kind of ironic because now all those things are put together in my field now. But it was just really kind of a coincidence, but a happy coincidence. And sometimes that's how things happen in life. You just let things fall in. But also when you kind of like let yourself open to what's around you and willing to learn from people that are around you, you discover things that you would never imagine. Like, now people know more about this field because of CSI. And, yep. At my time, there was no CSI. There was no... the closest was Columbo, maybe, for people that know that detective. Yep. But, it was really like completely foreign to me. So when I discovered this, I was completely amazed at what you could do. And also the freedom that you had, like intellectually, and also that kind of like contact that you had with your mentors, that was a kind of a back and forth type of exchange of ideas, and not very not dogmatic. That's what I really liked. Is what, like, day one you could learn something, and then day two it's completely changed by something that you found. And that for me was just amazing. So every single one of my days right now has been just to reconstruct what I learned the day before. So, so that's something that I really love. So you kind of like put yourself in the mindset of a kid once again, but now with more a kind of like take on your life and, you know, decision and stuff like that. So it was just basically, maybe it was chance, maybe it was serendipity, some people say, but yeah, it just happened basically.
That's so interesting. So I have many questions. Let's take a step back. So social work in South America, Army, was that together at the same time? And like, how do you go from there to wanting to go to medical school to then ended up in biochemistry?
Yeah,
give us like a kind of a chain of events, because I think you're the first guest who has, you know, military experience, social work, and then ends up in the quote unquote wrong class or wrong field.
Before we continue, I want to ask you something. A lot of you listen to this podcast but haven't subscribed yet. If that's you, this is your sign. Subscribe now and leave us a review if you can. It grows our GPCR community. And speaking of community, a couple of things worth mentioning before we continue the conversation. The Dr. GPCR University offers live and on-demand courses designed around real GPCR discovery challenges within an ecosystem that puts the field first. And the Terry's Corner is where pharmacologists at any career stage sharpen their thinking along with Dr. Terry Connect. Live workshops and AMAs where you bring your actual questions. Thank you to Eurofins, DiscoverX, and GeneTex for being part of this community. Sign up to the Connect and Brief newsletter to stay in the know about all live AMAs, live courses, and on-demand lessons. And join the Dr. GPCR ecosystem for upcoming live and on-demand masterclasses and community updates. All the links are in the show notes. And now we'll get back to the episode.
Yes, basically. Well, you know, my path is not classic at all. I kind of, it's a little bit part of my personality. And so it's something also that I try to convey to my students that, you know, be you, because nobody will, you know. So basically, you have to kind of like take advantage of your skills, of your personal skills, and try to exploit them and see how far you can go with those, keeping in mind certain objectives that you want to achieve, and not to kind of set your head on success. That's a big word that sometimes it's a little bit intimidating for me, this word success. So I hate to use it, but just for you to accomplish yourself through something. So for me, my accomplishments always came through helping. I love to be helpful. And that's all I basically tried to do. So joining the Army for me was just like that. I wanted to learn some skills, and through those skills, being able to help people that they probably, you know, don't have that chance. In the military, I had, you know, the kind of like the luck not to be involved in any conflicts, because that really wasn't my doing in the military. Of course, it's one of the backdrop of that job, but I never got involved in any conflict. So, but from that point of view, you know, you were involved in a lot of different communities that you would normally see if you were in a civilian life, and it kind of helped me broaden my horizon on who people are, and also what the value of people really. Sometimes, you know, when you're in a certain circle, you kind of leave other circles out just because of, you know, we make excuses, we think we're busy, or, you know, oh, we have the same interests and stuff like that. But really, at the base of it, everybody has the same interests. Everybody wants something better for them, for their family. They want to develop, you know who they are. They just want to be able to contribute. And from that point, that's always been my calling. That's why medical school was an option, because I thought that was the only way to help in some ways, because I thought health was so important, and that was But then when the science came, then I saw the way you can actually help at many different levels. You know, sometimes it's hidden. I thought would be hidden in a lab, you know, but just in parentheses, if anybody tells you that you have to be an introvert to be a scientist, it's completely wrong. because you have to talk to so many people. You have to be really the face of your lab, the face of every project that comes out of your lab, and it's very difficult to be an introvert now in science. But this parenthesis being closed, so from that point of view, when this side of science was revealed to me, then I knew that's what I wanted to do. And so from all the social work that I did, I could basically continue doing the same, but on another angle with the scientist career. First, I didn't see it as a career, really. I thought maybe it was something in passing that I would find something else. But the more I was doing lab work and developing those projects, the more I knew, no, there was no way I was going to come out of this. So that's how basically I merged those. And of course, throughout all my scientific career, I was involved in the army. So I didn't leave the army. So, but I was a reservist.
And this is the Canadian.
This is the Canadian, This is the Canadian Navy. So it allowed me to kind of take time off and be like they call it a supplementary list. So a list where they just call you if they need you. But in the meantime, you're free to do what you want. And that's when I was able to, explore all these different facets and be involved in different things at the same time as I was in the military. Yeah.
Nice. And then I cannot believe you turned down the admission to med school. I think a lot of people would have said to themselves, okay, I got admitted, I'm just going to go and do it. But then you fell in love so much with science, they were like, yeah, no, thank you, I'm good.
Yeah, it's strange because I thought at the time when I received it, it was like summer, the summer, exactly in the middle of my kind of like summer training in that lab where I would end up staying, for all my graduate studies. And it came at a moment where I was not, I kind of like I had forgotten almost that I had applied. And because in Canada, you have to apply kind of like in January, and then you do some interviews in March and stuff like that. Yeah. And then that's when I realized I didn't really know why I applied at that time. I kind of second asked myself, why did I do that? And that, but I had to consider the offer because, from coming from an immigrant family background, like the medical school and medical trajectory, it's the, it's the one every parents want their immigrant.
Yes, I know it. Med school, dentist school, lawyer, and then the rest is definitely not scientist.
Exactly. No, nobody thinks about science at that level. And so I had to kind of ask myself, really, if I should turn that down. But that's when this thing of, be you, because nobody will kind of kicked in. Because then I was like, why would I go to medical school? Would it be for me, really? Or would it be just like to achieve some sort of status or something like that? So then I realized it was not based on anything real. So for me, at least. And so of course I contribute. I collaborate with a lot of physicians and pediatricians and stuff like that. And I like this collaboration because I see other aspects that I don't really see in the lab. But for me, I think the calling really revealed itself once I started doing those experiments and being able to change stuff on a day-to-day basis. So when I turned it down, people say, I know you made a mistake. You should have. But it's been I don't know how many years, like maybe 25 years ago, and I still don't think I would have, I would never look back on this decision. But it was a turning point. It was really a turning point at that time. Yeah. Mm-hmm.
You made many important points, and I think it's especially important to call them out for the young generation, for the scientists who are, thinking about an MD, PhD, or a PhD, or be you. And I love the fact that you just said it, and it's really about who are you doing it for.
Yeah.
And it sounds to me that you continued and you went into science because you loved it. You ended up in science somehow,
yes.
But then you realized that you love it. And it's so interesting. So you mentioned that, you thought it was chemistry and it wasn't, it was biochemistry. Was it because, I know when you apply for university in Canada, you have these three choices.
Yeah.
So my guess was that it was medicine and then biochemistry and then I guess chemistry, your third choice?
Exactly. Yes. So it was in that realm. And also you apply for different universities. Yeah. And so this one, I think my mom had asked me to apply for, for this one because I had put all my eggs in the same basket, applying for medical school in Montreal. So for people that are not accustomed to like the geographical setting, Montreal is an island, and every kind of like the heartbeat of this province called Quebec. So everything happens on that island. A lot of things happen on that island, and I was born there. I lived my whole life on an island basically, and then I was going to the mainland. So basically, this university, Sherbrooke, I didn't know really a lot about. So it's outside of the island and it's south of Montreal. So for me, it was also coming from this kind of like summer training in Nicaragua, helping people in another country. It was also refreshing to come out of the island, to go to another university that was not, what I would classically go for at that time, to stay on my geographical area. So I was able to kind of come out and live by myself. Also, I left the family home and stuff like that. So that was a kind of a whole experience. But because of that, I hadn't really thought that I would ever come out of that island. Yeah. So when I got this acceptance to that program, I really didn't really look at what it was, because I know it was just a placeholder for me for next year to apply for medical school. So I was like, okay, I'm going to do it. I'm going to do it the best I can and see what happens so I can have the best grades and apply to medical school again.
Yeah. So a lot of people did that. And it's so interesting because you mentioned, being born in Montreal and doing everything in Montreal. And that's pretty much, I wasn't born in Montreal, but that's pretty much what happened to me. Living in Montreal, going to a Francophone school. Obviously, you applied for the University of Montreal. Somebody asked me, why didn't you go to McGill? And I said, I never even thought about it. Maybe it would have been different because the system is different.
Yeah.
At McGill, but kudos to you for moving out of the island and then going to Sherbrooke, which I think it's a really nice area.
Yeah.
It's a good university. It's a small little town compared to Montreal, and culturally, it's very different than Montreal.
Yeah, it's very different. It also has this because with the history of Canada, with the colonization of the French and then the British. So this kind of like southern border type of towns have a really kind of like the infusion, big infusion of both kind. So you can see it as different levels, but it's less integrated a little bit than Montreal, for example. So you still have like a British side, the British descendants, and you have the Francophone side. But it's a very nice town. And at that time, it was kind of like a renegade type of university, because they were trying all these new programs. And I'm not 100% sure, but I think University of Sherbrooke and UQAM, which is another university in Montreal, came up with those programs that integrated the learning in the industry. So you were able to within your program to basically have 1 full year in the industry without that affecting your grades, but being part of the curriculum. So at that time it was kind of new, it was kind of fresh, and I like that about that university, that you had less barriers to the learning kind of process, but also the strategies for learning.
I love that. And then it's funny because I think about my time at the University of Montreal, and it was a little bit similar to you, that I did my bachelor's, master's, and PhD in the same program in biochemistry at the same university, the training in the same lab. But I do remember that the structure of the courses during the bachelor's was a very French program. So you had to go through these steps. You couldn't pick and choose. It was one class that went together. And then you had to go through that class, graduate that class in order to take the next year's class. And if not, you ended up in in the situation where you are in a different group, you can finish on time, which is not the case based on what you're saying at Sherbrooke, and it was definitely not the case at McGill.
Okay, yeah. So it was more rigid, as
It was very francophone, very French.
Okay.
Not Québécois French. It was very français.
Okay, yes.
That rigidity that comes with it. Then again, I was raised in it, kind of, so it seemed natural. Now looking back, I don't see why not. You could have, chosen the courses and then having the opportunity, as you mentioned, being in industry a year and learning new things and broadening your horizons.
Yeah. Oh, yeah. That was at that time kind of a new way to approach it. So I kind of liked it, and maybe that a little bit the basis of my choices, also how I see also now that I give classes and that I contribute to the training of students. It's also, I think, an element that I try to infuse to them, that nothing is set in stone. Also, for once you take a step, you can always take a side step. You can't be afraid of those moves. And it's because it's all going into one direction, into making you a person with more skills. So that's why you have to embrace.
Again, you're making a lot of great points. The BU, the fact that there's not only one path, it's not one single road, not point A to point B to point Z. There's multiple turns and twists that you can and you should try out. You shouldn't limit yourself. And it's all goes back to like becoming that diverse or versatile person.
Yes.
And the one last thing I may want to add to that, and just because others tell you it's not the way to go, doesn't mean it's not the way to go for you.
Exactly. Yes. Yes, because everybody is different. Everybody does things different at different period of their life.
Yeah.
So it's just, circumstances, and what you kind of integrate those circumstances and try to make the best out of them every single time. So that's good. It kind of, now that we're talking about this, but it kind of takes me back a little bit because not many people know that, but I lived a little bit in Haiti because my parents were moving there, and I was caught a little bit in the civil war, the war when the president got kicked out. There was a lot of instabilities and stuff like that. So living there with like the low resources and not being able to come out, or if you would come out, it was very kind of dangerous kind of like situations, and also having like not many resources for the everyday thing like food or something like that. So that kind of like puts like another perspective on things, like when you have choices in front of you, so not to be afraid to take those steps also, because circumstances will change. At that time I thought I would never come out of there, and that would stay there, and probably in the worst case probably die there, and because of the dangerous circumstances, and it came close a few times. But I was able to come out from the help of many people, but I was able to come out and to get to Canada and to be to go back to where I was born, and to develop something I never thought I would be able to. That's why actually when I joined the military at a young age, it was because of that, because I couldn't imagine not taking advantage of those opportunities. And when I saw what people were doing in that branch of the Army, I was like, wow, you cannot just let that go. So at that time, that was my choice. So at different period of my life, I made different choices, and it would never be the same choices as when I was 20 than when I'm 40. And that's why sometimes, it's hard for me to give advices to people, kind of life advices to people, or what they should do, or what the best advice for this or that. I mean, the thing is, you evaluate where you're at. And I think, just trust yourself to make the best decision at that time. Mm-hmm.
You made a bunch of, again, great points, which are, I think, that they need to be highlighted. And you mentioned, being caught up in the Civil War and being in a situation like that, and understanding that resources such as food, which I think a lot of people in the Western Hemisphere just cannot understand. not having food or not having electricity. And full disclosure, I grew up in Algeria at a time, we left, but at a time where the terrorism was really at a high level. Happened walking to school, hearing gunshots, not being able to going to school because the whole area was closed off. They were looking for terrorists, or, having just that one pair of shoes that, if something happened to it, you had no shoes to go to school, or, not having enough food on the table. But I think those things need to be spoken about because they determine who you are as a person, and they also make you value what you have.
Exactly.
And one last thing, I think they also make you realize what's important. That's
true. The core of what's important.
Exactly.
Yes.
Exactly.
Yes,
definitely.
And in a way that shapes who you are. I became a scientist because of all those things. And the way I approach my science right now, my lab, my lab is 100% kind of accepting of everybody that wants to come mainly from poor backgrounds or like kind of like marginalized backgrounds. So I try to incorporate my lifelong experience into how I kind of like direct my lab right now. So it shapes you in different forms.
It does. So yeah, I think it makes you reevaluate what you call a failure and what you call a success.
Exactly.
Which is why I always say I don't like the word failure. I like the expression lessons learned. What not to do.
Yes.
What not to do. All right. Before we go back into the GPCR world, let me take a super step back. As a teenager or as a child, what did you want to do? What did you like to do? Were you more into science or more in, community type of work? Did you, how were you as a child?
Yeah, as a child. So as a teenager, I didn't really have like some sort of, I like to do everything. I like to put my hands on everything I could do. I was very high energy child, but because of that, some people also try to kind of take advantage of that. So I made some bad decisions on the way at that time because I had so much energy. But then when I became a teenager, then I really kind of like did like a 90 degrees completely. I decided not to direct that energy in anything bad anymore. I didn't want to be involved in stuff that wasn't helping, that wasn't productive in a social kind of aspect. So that's at that moment, I really involved myself in that military because I joined around 15. I joined at 14 years old. And from that moment, I just tried to basically live the most I could from that experience. So learning how to, ride boats, navigate, and communicate in Morse, and so all these different things that I would have never learned in the civilian kind of like setting. So I think also from that, I also discovered myself, what I could do. And basically, you'll be surprised that you can basically do almost everything. as long as you try, you can basically achieve basically everything, and not always on the highest level. That was never my goal, but always to get the gist of it, get the basic of it, and be able to kind of maneuver in those environments and be able to, when I confronted with a situation, for example, that involve these aspects, well, I would be able to react and make decisions based on my skills. So that's basically what I like. And because of that, I think like the capacity to adapt, that I kind of developed from that experience, helped me kind of like be able to do many things also during my career, also as a scientist, I became a chef at one point also. So I dedicated myself I opened a restaurant in San Francisco, and kind of it's underground restaurant. Back in the days that didn't exist. I think we're only like 3 in the Bay Area. But so because I knew I had those skills, I wanted to just exploit them, and it worked very well. For some people that saw the Netflix series Chef's Table, you can see me on the second season on the Mexican restaurant of Olvera, and this is a good restaurant here that's called Puyol. And that's because I always try to kind of like open my how do you say my realm of possibilities, also of my skills, to just apply them. And that's what really makes me happy, and that's always made me happy from the kids, the teenage years until the adulthood, is to be able to do something productive with whatever I have as a skill. That's always like kind of exciting to me. And explore. That's also what I really like. Like as a kid, I would always explore stuff. Like, if a house was open and there was nobody in it, I would like to go in there and visit. And sometimes construction structures that were up, I always like to go in there. And so exploration of the world that came later when I started to open my horizon and travel and go to other places and kind of insert myself in different cultures and stuff like that. I did a exchange of 6 months in a Jewish school, for example, and that completely also opened my horizon. It was in Montreal. So it's all different experiences that kind of shape my character as an explorer. I love to explore. I love to explore my skills, but I love to explore what's around me, and also I learn a lot from people. I like to extract a lot of people that are around me, and sometimes even my students are surprised that I kind of like trust them so much, and I really listen to them because on the kind of rigid system that we have here in Mexico, they're taught to only listen and kind of like take in what they've been taught, and there's not really a lot of back and forth. So when I give them that opportunity, they're really kind of sometimes they don't know what to do with it with so much freedom, but it's all part of what I became today, what I was as a teenager, as a child. So yeah, it's
okay. Let me stop you here. Let me stop you here, because I don't think we're going to ever talk about GPCRs. This is so interesting. First of all, okay. I was going to ask you about the chef thing because we talked about it before starting to record, but I have many, many more questions. When do you sleep? Because the way you went through all of this, I mean, it's clear that you're an extrovert. It's clear that you're a high energy person, but having done so many things, the question is, when do you, how do you do it all?
Yeah, I tried to kind of be organized. I tried to also I always have my priorities, and when I think it's the right time, then I can, switch to the other priority. But really, like my life is kind of an open field. I like to, of course, my scientist career is the one that I focus more now. Although I had plans to open a restaurant here, but when the COVID hit, then it was kind of like I had to take a back step for that. But I do sleep. I don't sleep many hours. My schedule is between 5 and 6 hours. But during that time that I'm awake, I try to always advance a little bit a project. So sometimes it doesn't even seem like it, but if you do just a little bit per day, it ends up being like a huge advancement at the end of the week, a huge advancement at the end of the month. So then, when I opened that restaurant, it was basically from kind of a immigration issue that I had in the United States. I could no longer be a postdoc. I could no longer be employed. I was employed at Stanford University. And because of that, I had to find something else and to support my family So I had to find something to have an income. So suddenly I was without an income day one, day two. So I decided to just use my skills, and I just started reading. 1 week long. I started reading on cooking, how people were doing it and stuff like that. And I knew I didn't have the resources to open like a real restaurant. So I decided to just like send messages to people that wanted to just come to a social dinner at one point in my home. And it was a 8 seatings, just 8 people could come, but it would last the whole evening. So that switch to that part basically was because of like kind of like a bad circumstance, but then I changed it to
a good one. Yeah, you make the best out of the situation.
Exactly. And little by little, I started getting better, and then with the word of mouth, it kind of the word got out, and just like that, just like doing stuff little by little. Then, by accumulating also knowledge and learning, you just like end up making great stuff. So. Agreed.
And it's funny because, again, you make a bunch of great points. And I'm really hoping that, people who are going to be listening to this episode walk away smiling and going to sign up for Netflix and look at the second season of Chef's Table. It's funny because I did watch all of the series, and now that you mentioned it, I was like, oh my God, I have to go back and find you.
Yes, it's a very small part because they called me. They knew I was here, and the chef called me. He said, "Are you still doing your kind of like rebel restaurant?" I was like, "No, I'm here now, just for work. I have a position here." I said, "Okay, do you want to participate to this?" So, but it was again, because of this kind of like openness to different things. Yes. I decided to participate to the shooting.
I think it's great, and I do remember parts of Chef's Table. I can't remember which season it is. I don't specifically remember seeing you, but I do remember seeing a part about these underground restaurants. And it was in Mexico where people would come into homes and people would cook, and it was just they were showing how they were making the tortillas and the grains, and it was first of all, I think it's a great idea of inviting a small group of people into your home and then making them local food or very special food, and you discover a culture.
Yes.
But honestly, kudos to you. But the point I wanted to make is the thing that you mentioned, that you do sleep. You are very organized, and then doing things little by little. And for a long time, and I can speak of experience for a long time, I didn't realize that doing every day, putting in a little bit of time. And when I say a little bit of time, it can be 15 minutes every day to build something. At the end of the week, it's going to accumulate. At the end of 6 months, at the end of a year, you're going to see how much that 15 minutes every day counted.
Yes, it becomes huge.
It does. It absolutely does. I've been reading the literature, and I've been trying to get, keep tabs on the GPCR field, although I'm not directly in the lab working on GPCRs. I don't work in the lab anymore, but the 15 minutes or 30 minutes during my commute every day allows me to learn so many things. And I honestly, I put a timer on, knowing that it's 15 minutes, and in those 15 minutes, I'm not doing anything else. I'm focusing on a topic.
On that. Yeah, that works. That works. So it helps you focus.
Yeah, exactly. It's a matter of focusing, and it's a matter of just putting in the time.
Yes.
And not realizing that 15 minutes matters.
Yes, totally.
There's this author, her name is Laura Vanderkam, and she talks a lot about time management and how to be good at managing time. She wrote multiple books. I think one of the books was called "What Successful Women Do Before Breakfast," "What Successful People Do Before Breakfast," and she was mentioning that there's 168 hours in a week. And then she calculated down how many hours you sleep. If you sleep 8 hours, this is the number of hours that remains. And then the question is, what do you do with that time?
With the rest. Okay. Yeah.
Which I thought was a really nice way. And she every couple of months, she does have this challenge where she challenges you to track your time in 15-minute increments for an entire week in order to figure out where does your time go.
Goes. Oh, I see. Yeah.
I think that could be really, really useful, but I don't think you have a time management issue. So what were you cooking in San Francisco?
Oh, that was interesting. That was because my background is Caribbean, so my family is from Haiti, but I never cooked Haitian food in my life. So that was actually at that moment, that's probably where I reconnected most with my roots, with my family, because then I would call every day. I would call my mom every day. I would call my aunts every day to say, how do you do this? Why do you put that? But the thing is, in San Francisco, there was almost no Caribbean restaurants. There was no Caribbean restaurant, that's for sure. There was no Caribbean supermarket where you could get the produce. So what I would do is shop in Asian markets to make my food. So basically, and I was trained cooking the classic French cooking. So basically, what I was doing is kind of a fusion. I would use French cooking techniques to cook Caribbean food, but with Asian produce. So when people would come, you would come, let's say, and eat taro root, for example, and the Caribbean, they do it a certain way. But then I would use French technique to kind of transform that root and be able to present it to the customers. So every single type of traditional Caribbean food did not look traditional at all because of of how it was constructed, but it was just this kind of like also this fusion that attracted a lot of people. People wanted to know what it was and where it was, and also because it was more like an event. So people would get to the place. They would have not food right away. First, they would get to know the other people. We would have like board games to start, and then people would get to know each other, and then would have dancing also later in the night. So it would be like a 6-hour-long type of event where we would cook. And since I wasn't very good with pastry, I would have like a pastry chef that would collaborate with me from the cooking school, the culinary schools in San Francisco. So that was really like a full mix, and that's what I love because San Francisco also is very kind of like multicultural type of environment. So everybody that would come from there were people from Asia, from Africa, from the Caribbeans, from Europe. Everybody would actually love the environment, and everybody learned in those occasions. So yeah,
it was more of a social event.
Yes,
it goes back to your roots of being social and bringing something to people.
Yes, exactly. Because that's what was exciting about this was like to have many people around the food that I would give them on the table. They never knew what they were going to get because it depended on what I found in the market the day before, and so it was always something fresh for them. But also I really loved their take on it because they would be like, oh, wait a minute, this is like what my grandma was doing, blah, blah, blah. And for example, if I would do, for example, congee, for example, people would be, oh yeah, I remember when I was sick or when it was cold outside. I remember this meal and so such and such part in China or in Hong Kong, my grandma used to make this. But why is it relevant for you? And then I would explain them the kind of the relationship. So it was always a joy for me to see the feedback and to see how people kind of reacted, but also how it kind of like brought back all those memories for them. So at that moment when they took that mouthful and I would see it, I would say immediately, it was like, oh yeah, it was almost like immediate.
That's so interesting because every time I think about taste, I think about GPCRs, but then you kind of in just one event, in one dining experience, you use so many skills as scientific skills, but at the same time, GPCR related, and then the culinary skills. Did you go to culinary school?
No, so I wasn't formed as a chef at all, like formally. So I was kind of like I learned from a friend of uncle of mine.
Okay.
So then he was a chef. He was a French chef. So he showed me how to make sauces. So that was my first introduction to those techniques. And then he went from there. And then we would cook from time to time. And when I thought I had enough skills, then I would, make it for bigger groups. And I catered, for example, some events like that. And then that's when it happened. I basically kind of like self-proclaimed myself as a chef at that time because nobody knew me in San Francisco. I was, I didn't work, because also in San Francisco, there's all this kind of postdoc type of way of to work in that industry. So, for example, there's French Laundry, which is a Michelin star restaurant that is well known throughout the world. So a lot of people come from there and then work on other restaurants, stuff like that. So I didn't go through that postdoc,
like legacy type
exactly.
Yeah.
So I was completely, out of the blue. But because of that, I think people were attracted to the method, and
I think if the food is good and you have a good time, it doesn't matter who you trained with, whether it was with Gordon Ramsay or anybody else.
Yeah.
It's the result that absolutely matters. Have you ever thought about putting together a cookbook?
I thought about it. That's a very good question. I thought about it. Because of my reconnection with my Caribbean roots and all the stuff, and I thought it was getting lost a little bit because of all the political situation. Less focus is put on that because now people are just trying to survive and try to do their everyday tasks. So I thought, I did think about putting together a cookbook that would revisit, but the old recipes and the kind of like, from before the Haitian Revolution, from like even during the colonial time, the slavery time. So revisit those recipes, but with a fresh kind of look and adapted to, because here living in Mexico, we're very lucky. Basically, it's like the refrigerator of the world, like the pantry of the world. There's everything here. So with this flavor, with the Mexican flavor. So I did think about it.
I think you should. I think you should. I think you should. Yeah. And it would also, I understand that, with COVID, you can't think about opening a restaurant right now, but I think being able to create those dishes and then making that cookbook while we hopefully get back to what a semi-normal state could be a great way to already plan those dishes out. So at least set up the foundation for when you'll be able to open your restaurant.
That's true. Yeah. A bunch of ideas. One of the ideas was actually to have a migrant food, because the thing about migrant food is always something very compact, very also full of flavor, but in like small bites. Yeah. So a lot of cultures have that. So basically the purpose before COVID was to exploit the migrant food from different cultures. Yeah. So to have a restaurant like a food truck or something where
I was gonna say
exactly
you just have a food truck
at home. Yes.
Yeah. There are I love the idea of that the food truck idea, because then you just pack it up and then go. And you can still bring in really great flavor, really being very artistic at the same time. It reminds me of the movie Chef, with Jon Favreau.
Just yes.
And I really love that movie, and I really love the fact that he started at the bottom because of everything that happened without giving it away, and then was just an idea of starting a food truck, and look at where he got. Yeah. And every time I watch that movie, I get hungry because it's just everything looks so amazing.
Yeah, they really convey it well. So
the feeling of it does look amazing. All right, so you were a postdoc, and then you converted. You went from Dr. Boucard to Chef Boucard.
Chef, yeah.
How did you end up in Mexico?
So Mexico was also that openness that I was talking earlier about, and that exploration that always inhibited me from earlier on. So when I finished when I was still in my postdoc and you're applying for places, like everybody else, I was applying to the big markets. So Canada, United States, Europe, Germany, France. So that's in England. So basically that's where, everybody wants to go because, it's the reputation, but to me, there was something missing for me. I didn't know if I really wanted to stay in those markets because I had been in there for a long time, and for more than 10 years working as a postdoc and also as a faculty in Stanford and Dallas and UT Southwestern. So I kind of knew, I felt like I knew what it was to work in those markets, but I felt like maybe with my experience there was like maybe 10 other people like me or 20 other people like me that could do the same in those markets. So I felt like maybe I wasn't as helpful that I would like to be. So I kind of decided to explore outside of the United States and those big markets. So I explored in China, but because of the cultural barrier for me, it was more difficult to integrate myself there. I considered it, but then I chose other markets. And then when I came to Mexico, because I never went to Mexico before, I came here, I saw that, okay, that was the right mix, the right fit for me, culturally and geographically. It was close also to my family. And I could basically also do good science in that market. So I thought, yeah, I could really contribute to something that wasn't there before. So there's nobody working on Adhesion GPCRs here in Mexico. So of course, it gave me an opportunity. There's nobody working on synapse formation, which is a kind of a sub-product of working on GPCRs. You can work on many physiological events. So mine was the formation of synapses, those junctions that are in the brain. So this came all together as not only I could put my skills up front, but in a place where they weren't exposed to it before, and I had access also to a pool of students that traditionally were not favored. So that's why also I chose Mexico City, because it's a lot of people from the Latin America area come there to study, because we have this huge university that's called La UNAM that has like more than 200,000 students. It's huge. It has its own city and kind of its own zip code in Mexico City. So it attracts a lot of people from the Latin America and also from communities that are also isolated or more or less isolated in Mexico itself. Many of you know that we still have like indigenous languages and indigenous groups here in Mexico. So not everybody speaks Spanish. There's like more than 50 other languages. So it brings them to my lab. So I've had opportunity to have people from Chiapas, which is completely in the south of the country, from communities also that are smaller, up to the north of Mexico, which is close to the border with the United States, and seeing all these different kind of life experiences and cultural. So to have access to that for me was really gold for somebody with a background like mine that comes with a social kind of point of view to everything. So it was gold. And that's why basically I decided to come. Is all these conditions were completely reunited. Yeah. And I knew I could really benefit myself, but also give a lot to the and I'm not Mother Teresa, I'm not like, but I really love to do something helpful, and really, for me, that's really the word for me. Be helpful, contribute to something bigger than yourself, and be able to not do it all, not be like, the jacks of all trades. Choose something where you're good at and that you're not excellent at, that you're not going to probably not be a big success, but you can be very good. You can be, and those people can help you become better. So that's the path that I chose. And so for a short answer, Mexico was the mix for me and was the right place for me so far. I've been here 8 years now, and I still love it. I still find, everyday things that I can, can improve. And my contribution to my new society now, my new social
Productive
environment.
society. Yeah.
Exactly. Yeah, but I tell people, a little bit of a joke. I try always to move south. I started in Canada and then went to the United States and now Mexico, trying to get closer to the equator. I like the warmth also.
Yeah, that's what I was gonna say. I think it's a social thing, but it's also the weather is not a bad thing either.
Exactly.
And the variety in food, so you can also cook.
Exactly.
Different meals.
Exactly.
That's so great. That's so great. So let's get back a little bit to the science. And although I think you're a unique guest because you've done all of these things, and there's so many take-home messages from our past couple of minutes that we've been talking. And let's move on to the GPCR part. So you mentioned that you were in Sherbrooke, you worked on GPCRs, then you were in Thomas Südhof's lab, and you worked on adhesion molecules, and then now you're working on adhesion GPCRs. Safe to say that adhesion GPCRs are your favorite GPCRs?
Yeah, pretty much. Yeah, because they kind of like integrate everything that I love, because I was always intrigued by how cell communicates, how you can actually pass one external signal to an internal one. Now it's obvious. No, it's all receptors, stuff like that, but we know so little still. We know so little about those. But to me, it kind of like, compounded the cell communication that I like. And adhesion GPCRs in particular, because I started working on classic, family A type of GPCRs, more particularly the angiotensin receptor, the urotensin receptor. So it was like kind of a one gene produce, one kind of like one no splice variants in that family, very kind of like upfront good receptor, solid, and then I ended up studying those cell adhesion molecules, were not GPCRs, just like single pass transmembrane proteins that were full of splice variants and all those things. So very complicated genes. And then I found out that adhesion GPCRs were kind of like taking both aspects together. So this adhesion, so for cell communication, but physically being able to join cells, and on top of that, also be potentially also signaling, to G proteins, and be like those transducers that we know from the classic families. And now we're just starting to kind of like appreciate this aspect of those GPCRs. They're called GPCRs just because they were 7 transmembrane domains, but up until recently, we didn't know if they were really GPCRs, if they were really G protein coupled. So so that was that was my interest, because also for some reason, again, that's also something that happens a lot in my scientific career, is kind of like chance. Sometimes you just as a parenthesis, my first paper in my master degree was basically based on something that I forgot on the bench, and I decided to analyze it when I came back from a weekend, and it gave me a great result that I was able to replicate, and boom, that was my first paper. So when I was in the lab of Thomas Südhof working on those cell adhesion molecules, I decided to just test something to see if there was actually a kind of like how do you say that, like a relationship between those two families. And I decided just like that to test, like everything starts in a receptor field, to test the binding of something to something else. And I decided to test many pairs, and I found out that one of the cell adhesion molecules I was working on actually bound to a GPCR that I wasn't working on. So I was like, well, bingo, I always wanted to go back to the GPCR field. So I tested those also to the advice of one of my coworkers, who said, oh, you should try this, maybe you never know. Maybe it does bind, and it bound, and it formed also they were able to adjoin cell. They were able to form an adhesion complex, an intercellular adhesion complex, which was great because then that was the start of a new project for me and for my career. And it was, again, just like being open to something sometimes, because like a lot of people say, there's a lot of reasons not to do an experiment. There's a ton, but sometimes you can just do one, if you have the possibilities to do so. And it ended up being that those two proteins that actually we knew from like 10 years before were binding this toxin. There was like a toxin from the spider. It's called latrotoxin, which came from the venom of the black widow. So we knew for a long time that they had receptors in the nervous system because they would elicit some nervous system phenotypes like paralysis and a huge release of neurotransmitters at the synapses. So we knew they had targets there, and the targets were discovered, but nobody had put those together before. And my colleague was like, well, if they both bind to the toxin, maybe they actually do something together. And that's what we've been on so far.
That was an educated guess.
Yes,
that was a very educated guess, and you had to answer that question. I mean, come on, if both binded and they are expressed in the same cells, then they must be doing something together.
Exactly. And it was just a matter of trying. And I tried it. It worked. I didn't want to believe it. Thomas Südhof also didn't want to believe it because he worked on this for 15 years before I made that discovery. So that's something. And then, I guess it's still controversial, that aspect, but we try to provide evidences, more and more about the functional aspect of that interaction, so that it becomes less and less esoteric for people, but and for us too.
I understand the difficulty of working with the Adhesion GPCRs. I mean, I've seen, Ines Liebscher and Simon Fromel also work on in the field of Adhesion GPCRs, and I've read a couple of their papers, and I always find Adhesion GPCRs as being these very unique receptors that can do so many things, and especially I think it's very confusing with that long N terminal. And the size. I mean, 6,000 amino acids. I mean, come on, that's 10 GPCRs in one.
Yes, they're huge molecules. And also, not only that, but they also come like in kind of two flavors, type of two subunits at the membrane. So not only they're produced in those big chains, but these chains can be proteolized, like an autoproteolysis process that at the membrane. So they're present in kind of like two machinery. So it's a little bit scary when you approach adhesion GPCRs at first, because a lot of them are still orphans. We don't know ligands. We don't have any ligands described for them so far, but I think that's gonna kind of like be resolved in the next 2 or 3 years. More will have a ligands. So that's kind of a scary aspect for them. But also there is like dealing with that size, in kind of like heterologous system where you have to overexpress them. And also if you want to study them in their physiological context, then also they have all those splice variants. So that makes it also complex genes to study. But that's part of it. That's part of the challenge of studying adhesion GPCRs. It has this difficulty, but it has also those moments where you're like, wow, okay, now we're starting to understand those machines. And you had, for example, Demet Arach on your show, and many others also in the field that study structures, those adhesion GPCRs at the structural levels. Well, these are studies from those labs are really bringing a lot of knowledge that we didn't have before. And, from the plethora of structures for classical GPCRs that they are in other families. There's just one for, for just the main domain of adhesion GPCRs. So that's going to slowly change. Those structures are going to coming out from those labs also, like of the likes of Demeter, for example, and try to infuse the field with more and more of those knowledge that we didn't have before. So that's basically what's kind of, I think that's what's gonna kind of like, as you say, like project the field a little bit further. All those structural elements that we're lacking. Mm-hmm.
And how do you because to me, the way I see it in Adhesion GPCRs, it's like this huge, very interesting system, very difficult to work with, very chaotic at the time, just maybe because I'm not in the field. How do you choose what to work on in such a difficult field? Like, what do you work on right now in the lab?
Yeah. So what do we work on? So basically, it came from being interested in, of course, those kind of like molecular machines that are the GPCRs, but really also is the context where they're involved. And for example, these adhesion processes are really, it opens really a Pandora's box, because it's involved in almost everything from development to adulthood, and also adhesion processes and degeneration processes. So really, the being interested in what to work on means being interested in a biological event, a physiological event that you're interested on. For example, in our case, is the formation of synapses, and how the molecular code involved in those adhesion processes that lead to synapses, how they're determined by the cell, how they're laid out almost like a dictionary that has to basically be deciphered along the way. So for us, that's what really interests us, is basically in pathophysiological context, for example, in disease, in disorders, and more or less a psychiatric disorders, for example, like ADHD, for example, attention deficit hyperactivity disorder, autism, for example, bipolar disorder, schizophrenia, and these, how they actually rely on the function on those proteins. So we try to study processes like, for example, a synapse formation in the context, for example, of addiction. For example, addiction to drugs, because they involve a reward pathway in the brain that is often affected in a lot of psychiatric disorders, like schizophrenia, for example, autism, that has sort of like a different type of reward, a mechanism involved that is social reward. But so all those kind of center around this area in the brain that is responsible for maintaining that reward active. So that's what we're interested in seeing how those adhesion GPCRs, as those molecules, affect those pathways. And also, because it's adhesion prone, we're interested also in looking at a kind of like tumorigenesis, so cancer events that involve the loss of adhesion versus the recuperation of adhesion, but with different sets of molecules and different dosage also of those molecules at the right place, because also it's all a polarized process. So we try to put those GPCR that we love, but in a physiological context that we also love, and that we also think will bring the knowledge further. So we try to focus in the lab in those different aspects of physiological events related to GPCRs, and also, along the way, to see some transversal knowledge, because something that you learn in the context, for example, of cancer can be very useful in the context of synapse formation, for example, or in the context of communication in lungs, for example, or in secreting insulin, for example. So we try to see if the knowledge can be passed on to different areas, just based on the basic, how do you say, discovery that we made.
I love it. I love it. I love the integral aspect of it, and really focusing on the phenomenon, and then really drilling down. And again, I think even in your science, the social aspect of the work that you like to do is you're really being a social worker when it comes to the different diseases and these different physiological events. But that leads me to my next question. If you can give us an idea about what type of assays do you run? Like, what do you do specifically in the lab?
Yes.
How do you try and answer these questions?
Yes. So basically, we start from a standpoint of cell biology. So because we work a lot with cell cultures, with primary cells, for example, or cell lines. So we approach it on what happens to the physiology of the cell in different contexts. When we, for example, express those receptors in those contexts, or if we silence those receptors in that same context or different contexts. So what we try to develop in the lab is techniques that would help us exactly decipher those signaling cascades, for example, inside the cell. So, of course, we rely a lot on nowadays on BRET, BRET assays. Everybody's doing BRET. A lot of BRET assays being done also in our lab. And now with the different tools that exist, we try to decipher also what the signaling cascades also can be for those adhesion GPCRs, involving different aspects also of their I would say molecular behavior. So we use those assays, and we also look at a lot at the cells themselves, how those adhesion GPCRs change the morphology of the cells. So we study a lot the cytoskeleton of the cells. There's many types of cytoskeleton, the actin, there's intermediate filaments, etc. So we try to see how, and because also we were able to describe such a change in morphology, how those adhesion GPCRs change these cytoskeleton component to be able to integrate them in a different process, which could be migration, motility, for example. So all those that are involved in kind of like a movement pattern of the cells, because even in synapse formation events, for example, there's a previous events where the neurons have to migrate through like a forest of other neurons, and through their molecular determinants, they can find the right partner. So we try to apply this in a reduced system and try then to go to the more complex system. So also we use a lot of biochemistry, because the difficulty working with adhesion GPCRs is that their ligands are actually membrane proteins, so they're anchored to the membranes. But we try to kind of adopt strategies to be able to kind of like take them out of the membrane, make them soluble, and then be able to work with them in a way that is a little bit more easy than to have to work with them anchored to the membrane. So we use a biochemistry to engineer those proteins, a molecular biology to engineer those proteins, and then biochemistry to try to purify those in high kind of like high purification schemes. And also, kind of like attached to that, we use also kind of ways to see how those complexes actually stabilize cell junctions. So not only the signal that is transmitted inside the cell through BRET assays and microscopy assays, and for example, to describe the cell that received the signal, but also what those junctions look like and how they're organized, and how they actually how they depend on the state of the adhesion GPCR. So we look, for example, we do a microscopy assays, for example, and also flow cytometry assays to be able to quantify those complexes, those cell junctions in a population-wise a sample, so population-wide sample. So we try to use as many kind of techniques as possible to try to answer a question. So and they vary. But when we have a question, we try to find the best way to answer that question. And sometimes it's techniques that we have in the lab, and sometimes we don't. So we collaborate with other labs also to answer some of those, and also for them to infuse that knowledge into our lab. So our techniques are kind of very kind of diverse. The only thing we don't do is electrophysiology. we haven't done that so far. But everything else, from microscopy assays to biophysical assays related to resonance energy transfer, BRET, FRET, etc. Yeah.
Nice. It looks like it's a very diverse, toolbox that you do have, and I'm glad that you mentioned these tools. And the fact that, it's sometimes difficult to work with these Adhesion GPCRs because of their expression, their size. If you had a magic wand and you would, be able to manifest a new tool that you feel like it's missing, what would that tool be?
Oh, wow. Hey, magic wand with a new tool.
Yes.
I think a new tool. Well, that new tool, I guess, it will probably never be made, but it's something, we try to access with indirect methods. But my new tool really, if I would put myself in, like a really childish mind and, like a fresh mind, that would just be like a small, tiny camera at the surface of the cell and just like be navigating through all those molecules and be able to locate yours, almost like, like a Uber app that can locate your car on the side of the cell surface. You look at your receptor and just look what's around and be able to that I think if I had that magic wand, it's really like in a fairy tale situation, that would be something like that. A tool that would allow you to really see in real time, but at a small scale, what's happening on the cell surface. Yeah.
I think that would be great. I imagine ourselves, in these like NASA astronaut suit type of things, and then you end up in the cell, and then you can just watch the different events that happen. And obviously, it's in real time, but then you can appreciate each interaction.
Exactly, and see like the domains and also the dynamics of it,
yes.
Because that's a little bit our the bottleneck. Because even with like structural studies, we still kind of like stuck with it's a picture. When we take when we have a structure from cryo-EM, for example, it's a picture in time of that particular protein at that particular moment, at that particular state. So in that particular membrane type, etc. So we, of course, we cannot do everything. Probably the state of innovation is not there yet. But with that small camera, it's really to kind of like exemplify or illustrate, that this where the bottleneck is, where we could actually see the dynamic of it or something like that. So
I love it. I mean, people are paying a lot of money right now to get out of the earth and look down on the earth. And us GPCR people, we're just going to go down into the cells.
Exactly. It's a good analogy.
I love it. I very, very much love it. And we've talked about this throughout the whole podcast, and it's about advice to junior scientists. And I think our discussion for the past hour plus has been about advice throughout listening to your story. But what other advice would you want to give junior scientists or anyone actually listening to the podcast?
Yeah, I think it's basically, I think maybe other people have came up with it, but it's really like, don't be afraid to be afraid. Basically, like, when you have to imagine, like, when you're a kid, you come to school, your first day of school, you're kind of scared, but then you meet people, but that meeting other people led you to actually learn about the experience. You see that they have the same interest as you, and basically that becomes less frightening. And then you go to the classroom and they show you that map of the world, and then you discover that there's all these other countries. Then you're scared again. Then you realize, okay, I live there. Okay, this is less scary. This is my country. This is where I live. And then, oh, okay, my neighbor, their parents come from that other country. Oh, okay, so then it becomes less scary. So I think this is just also this explorator in me that basically it comes out. But when you're not scared to be scared, or you're not afraid to be afraid, you can actually learn a lot about life, about who you are, but also sometimes a lot in your experiments. Like when you do something, you're willing to take the further step and maybe take a little bit of a chance and stuff like that. And even when you choose the place where you want to do your graduate studies, or you choose your mentor, or it's always like a frightening experience. But if you willingly put yourself in a situation where you're willing to take risks, you're willing to, then things will fall into place. But it's not necessarily mean that you're going to be the most successful guy. Again, that word that I hate, but that you're not going to be, the first at it, but you might. But if you never try, if you never do it, you might not know about it. But the thing is, if you enjoy that ride, from the moment you put yourself in a situation where you're open to those risks, you will enjoy it, no matter what. No matter what is the end product, you will enjoy it. Whether you're there for a short time or you're there for the rest of your life, you'll have the best time of your life during the time you're doing it. So that's my only advice, really.
I love it. And it reminds me of that cartoon that has been on social media, the comfort zone circle, and then the rest where the magic happens. And I think, yes, it is frightening, and yes, but it's fine for it to be frightening. And it's just a matter of, getting used to exploring new things and doing something. And I love that you mentioned that multiple times actually throughout our discussion, that you learn new things. You didn't become the most successful or the best at it, but you became good at it. And I think oftentimes as scientists, we feel like we have to be the experts or the best. And that it's also cultural. I think it also comes from the culture that you come from. And we mentioned, parents thinking that if you're not a doctor, a dentist, or a lawyer, then you can't be anything else. But you can be just good enough.
Yes, because you have to realize you were less good at it the day before.
Exactly.
than the day after.
Exactly. So it's a piece by piece, and don't be afraid to do something new.
Yes, totally.
Super. 3 aha moments that defined your life in general, because I think you've had multiple lives based on all the different things that you've done. But as a scientist, or, and anything that you feel like defined who you are today.
3 aha moments. Oh, I would say one would be, I think when I applied for postdoc positions, so I applied to many places, and then I knew I wanted to go to Thomas Südhof lab. That was my first choice, but I applied to other ones because I didn't, I didn't think I would make it to that lab, because I thought, oh yeah, it's such a big team there, a powerhouse. So, not to put my hopes high too much, I applied to other places. And actually, my aha moment was like, everybody's human. I mean, it sounds so trivial to say that. It sounds so cliche or something, but it's such a moment where you realize you're sitting in front of those people. I sat in front of maybe 4 different Nobel laureates, Alfred Gilman, Thomas Südhof, Deisenhofer, Brian Kobilka, and more than 4, a lot of people. But every time they convey this, it's just normal people, even if they have this big trajectory and they created all those things, and they have all those papers, and they're really famous and big. They're just humans. I still remember this moment where when Thomas Südhof got the Nobel Prize, we did a small ceremony in a courtyard at Stanford University. Brian Kobilka came because he had it 2 years prior. The year before, I think, right?
2012, yeah.
2012. So then he came and, and it was the simple moment, everything was doing fine. And then comes a Michael, I can't remember his last name, but it was a Nobel Prize in mathematics that also had it the same year. And as a Thomas Südhof, he came and his wife came with him. And she took us aside and we're just having a discussion. And she's just like, I can't believe he won the Nobel Prize because at home, he can't even pick up his own socks. So these moments are like these places where you realize what you do in life is what you do in life. Like you do those great things in science, but you still that father, you still that brother, you still that sister or that daughter or so and so, that they still consider you, as a child, even if you're a grown adult. It's human stuff. It's human interactions. It's human behavior. It's just that. I mean, we amplify it a lot with all this social media and medium that we have to kind of amplify people profiles. That's normal because that's what we live in now, and we have to convey a message that is strong, impactful, short, and meaningful, as we say. But the thing is, when we finish with those interviews, when we finish with those papers, stuff like that, we still have to go home and sleep and do our regular task. And, like our kids still say, Dad, or they're still mad at us because we don't want them to watch Netflix anymore. Or the thing is, it's as simple as this, as in every day. And to me, I think that was a aha moment because I was considering those guys as like untouchable.
Yeah, but they still had to pick up their socks.
Yes,
I love it. I love it. That reminds me of a story. So I was in Tom Sackmar's lab, and he was a postdoc at MIT in Gobind Khorana's lab. And so based on what Tom told us, and anything you can read about Gobind Khorana, is that he was the simplest man ever. And one story was about the fact that one day, after he won the Nobel Prize, one day, 2 secret service agents came to his office, and they took him to the White House. Oh. And the reason was because since he hadn't won the Nobel Prize, the president wanted to give him a medal. And they called, they emailed, they sent messages and letters, and he would never cared about that. To the point that they sent the secrets, the secret police to take him, and then they brought him back. And another interesting thing was that he never picked up the phone, but there was a separate phone line that number was only known by his wife. And that's the only phone he picked up because he had other things to do. And, I love the point that you make that, at the end of the day, Nobel Prize or paper or celebrity, you're still human. You still have basic needs. You're still that son, daughter, uncle, whatever, mom, dad to those kids. And I think it's about just doing what you love to do and always trying to do something more.
Yes.
And the rest is just details.
Yes, exactly. Yeah.
I love the sock idea, the sock story.
It's very simple. And I think that's one of my aha moment. But it's been kind of like followed me because every single step of my career also, I still have this thing where I consider other people like, oh yeah, they're untouchable, stuff like that. But then I have to remind me actively that no, this is not the case. This is just this is life.
Yeah. And I think it also reflects very well this misconception, but I don't know if it's a misconception or if it's as you mentioned, social media, is that a lot of very good students who may be very good at what they were doing or they're destined to do something great are too afraid to email the Nobel laureate to get an interview or get a call or share their ideas. And this example that you just mentioned, I think people should think about the not picking up their sock, but having a Nobel Prize as to, I'm just going to email that person. Whatever happens after that is out of your control, but you did you took that step.
Exactly. Yes. Yes. Because if you don't do it, you will never initiate that thing that could be like something huge in your life. And, like for me, that postdoc completely changed my life, completely, really completely. And it was a small decision that I decided to take coming from the small, place in Canada and then applying to this big lab. And it was as simple as just establishing a communication and following up on this communication. And the thing is, if people don't want you, they will tell you. They will say, yeah, no, I don't have space, or try to apply next year or something, but they will say something. And sometimes you will have no response. Sometimes it happens because sometimes they're so busy. But try, do it, and then you will see the result.
You never know.
You'll never see the result. Yeah.
You never know. Definitely. Agreed. I love that. Any other aha moments?
An aha moment, of course, I think it relates also to those experiments when I published that first paper, that was like, oh, wait a second. Because I was so kind of like limited by the protocols. And of course, I was just starting. And I thought, okay, you could only do it that way and no other way. If not, it wouldn't work. And it was like an enzymatic reaction. So, but it's simple. Enzymatic reaction depends on the substrate for sure, the rate of conversion, but it's also time and temperature, So I guess, I didn't think about it, but I could just leave it more time. Yeah. And that's what I did when I forgot it on my bench, because I was going for the weekend, and maybe if my my former advisor listened to this, it will be like, oh, that's what. But it was a weekend. I had army training, and then so I forgot it on my bench. But then when I came back, I could have just put it in the trash and said, no, let me just run that sample and see what it gives. And that was, I think, that was something big, because then we actually solved something that we couldn't for months. Wow. Just at that moment.
Yeah, then, I think I've heard of stories of people getting their master thesis out of the trash because they were like, yeah, wait a minute, let me recheck something. And they had already thrown down the samples, and then they got them back, and there you go, they got their response and were able to reproduce the data.
Yeah, exactly. Yeah, that's the thing. If you're able to reproduce, if it's not, then
if it's not, it's not. But at least you were able to reproduce it, which is, I think, really important to keep an open mind.
Yes.
That's fantastic. Last but not least, and I ask this from everyone again, and I think you're located in geographically, and as you mentioned, it's a big university, and it's a really nice place to be. If you have job openings in your lab, where can people find you? I'm thinking of all these postdocs back up in Canada, freezing right now, thinking, I think I could go down to Mexico, do some BRET, and and be in a warm climate.
Yeah, because now, we have the same capacities as any labs in the world to do BRET and stuff like that. So if they want to find us, we have actually a website, so you can just type a Boucard Lab on Google, and you will see our Wix website, and you can see, for example, all the projects listed, everybody we have in the lab also, and when we have announcement for postdocs, for example, or students, we also post it there. And currently, we need people to work on our addiction project. So it's also posted on the website, and so it's Wix, the Wix site of Boucard Lab. You can find all the information about us.
That's fantastic, and we're going to put it on our website as well. So this episode was going to have a page, and we're going to put it there. But I can also tell you that if you'd like us to advertise your positions, there's just a quick form to fill out at drgpcr.com/career, and we'll be happy to share it on social media.
Oh, perfect. Okay. Yes.
See, perfect. BRET, facts, higher level questions, Adhesion GPCRs, and the Mexican weather.
Exactly. It's very nice. Mexico City is elevated, so we have always the same weather all year long. It's always 25 degrees during the day. Always. Maybe one day or two during the summer, it will go up to 30. But if not, it's always 25. Even now, when the winter is 25 degrees. But it's elevated. It's a dramatic city. We're surrounded by volcanoes. It's very, very dramatic landscape and also very densely populated, but also a very good opportunity to learn a lot about culture, about food, about people. And also, you're still close to the United States if you want to go, to Canada if you want to go, to Europe. There's flights over there. But on top of that, Mexico City is this clash, between the old traditions and new traditions still alive. So you still have people that speak the Mayan language, so the Nahuatl, for example, that are still present here, and they live also a very typical type of life. But also you have the New World when they came, the Spanish, for example, the French. So you have this nice mix of cultures here, and it's a great opportunity to learn a lot. New things and new cultures, and I still love it. So, but I'm biased.
That's great. Well, maybe we should organize a GPCR conference there.
Yes.
As soon as possible, but I think we should think about it, and it should be sometime in February when it's the coldest in Canada.
Yes, go to the beach or something like that. People know a lot of the beach, but also have probably a view of the city and everything that there is.
That's something to think about.
Yes.
All right. Thank you so much, Antony. It was great talking to you. I think we learned a lot about science, but also about, you're the trade of the jacks of all trades at this point. And we wish you all the best.
Thank you so much, and thank you for inviting me. It's a great experience. I loved it. You're very easy to talk to. It's just like a regular conversation, coffee conversation. So for anybody that wants to participate, it's a great media. I love the platform that you set up, and also the GPCR summit, the Dr. GPCR summit that was last year was a great opportunity to learn and about other people's work and labs. So I invite everybody to follow your podcast. It's really nice. It's really great.
Thank you so much, Antony. And obviously, everyone is welcome on the podcast. And I want to highlight this because before we hit record, we were just talking about this. You don't need to have 50, 100 years of experience in the field. Everyone is welcome from anywhere in the world, whether you're a student, a PhD student, a postdoc, master's, or you're a PI, independently of where you live on this earth. Everybody's welcome on the podcast. And I'm so happy that we finally got to record this episode.
Thank you.
All right. Thank you so much. Bye-bye.
Bye-bye.